In this lesson, we'll look at the IQ8 Commercial QD cabling. After completing this lesson, you should be able to identify the three sizes of QD cable and use the proper center tap plugs on site. QD cable is the 4-wire 3-phase AC bus that collects all of the microinverter output and sends it to the subpanel. Enclosed inside the sheathing are 4 12-gauge conductors. This wire size requires 20 amp breakers. The QD cabling is unique in that it provides the needed phase rotation built in to properly distribute power over 3 phases. QD cabling is available in 3 connector spacing variants: portrait, landscape, and the longer distance landscape ballast for east-west ballasted configurations or larger module frame formats. Let's take a look at the available QD cable lengths. Again, it comes in 3 different sizes depending on your panels, their spacing, and the racking system you're using. Portrait cable comes with connectors at 1.7 meters or 5.6 foot spacing and has 120 connectors per box. Landscape comes with connectors at 2.4 meters or 7.9 foot spacing and 120 connectors per box. And the longer landscape cable, which comes with connectors at 2.9 meters or 9.5 foot spacing and 108 connectors per box. Portrait cable is intended for arrays where the panels are butted against one another in portrait orientation with no spacing between east and west panels. Inverters need to be relatively close to one another in order for the connectors to be able to plug in to the next inverter. Landscape cable is for ballasted arrays in a traditional landscape orientation relative to the roof. It's meant for modules that have more common frame format. Though your panels are all touching each other and there's no space between rows, the inverters are quite far away from one another because they are in landscape orientation. Therefore, they require the landscape cable with longer spacing between drop connectors. The longer landscape cable is intended for larger module frame formats. With spacing at 9.5 feet apart, even the largest modules you'd want to use on a commercial site will be covered by that QD cable, though it is always a good idea to verify that, taking into consideration the location of any junction boxes or the module that you're using. Voltage rise is a concern when you're dealing with conductor runs as long as our QD cable. Enphase recommends you keep your voltage rise at less than 2%. All of our cabling options include a center tap connector intended to mitigate against problems that may arise due to voltage rise. You'll find that there is a center tap connector after every 6 drops on the QD cable. You should wire those center tap connectors to our center tap adapter cable and run that to your subpanel as a home run. When you wire in a home run at either end of the QD cable, voltage rise becomes quite high. But by wiring into the middle, your voltage rise percentages will stay within range as long as the rest of your ballast of system is sized appropriately. Placement of the center tap plug matters. You'll find that the center tap plug's placement will vary depending on the drop that you start with. Here you see a fully loaded branch of 12 IQ8P microinverters. We are starting from drop number 1. The center tap plug lives after every 6th drop, so we can see that when we start from plug number 1, the center tap falls right in the middle of the circuit, between inverters 6 and 7. But what if we start from plug number 2 because we had to cut it and start a new branch? That's not a problem at all, but you can see that there is now 2 center tapping plugs since they are after every 6th drop. Now there's a center tapping plug between inverters 5 and 6, and another between 11 and 12. Always use the plug that has the most drops on both sides. In this case, our first drop between 5 and 6 is much better because it has 5 on one side and 7 inverters on the other. That is much better than the second center tap plug because it has 11 on one side and only 1 on the other. If we're starting from drop number 3, the center tap plugs will be between 4 and 5 and another between 10 and 11. Again, we'd use the first one because it's much closer to the middle. The same principle applies when you're using IQ8H microinverters. In this picture, you see a fully loaded branch circuit of IQ8H microinverters. Since a fully loaded branch of IQ8H microinverters has 15, there will always be 2 drops in a fully loaded branch. When we're starting from drop number 1, the center tapping plugs will be between inverters 6 and 7, and another one between 12 and 13. We're always going to use the one closest to the middle, which means we're going to use the first drop on the left in this case. If we start from drop number 2, the first center tap plug will be between inverters 5 and 6, and the second one will be between inverters 11 and 12. Again, since we're trying to use the one that's closest to the center, we're going to use the first drop to the left that is between inverters 5 and 6, because it's closest to the middle and has the most inverters on both sides. If we start from drop number 3, however, the first center tap plug will be between inverters 4 and 5, and the second one will be between inverters 10 and 11, meaning that the second one is actually closer towards the middle than the first one, so we'll use the second one to minimize voltage rise.